Yeah. So make sure, like if that wasn't there, you would put 0x squared in place of it so that it keeps that all organized for you. Why do we have to do long division on this? Yeah, it's not just x plus 3. So we'll do long division instead. And how do we start? What we called round 1, I guess, before, right? Well, it was 2x into 2x cubed. And I recommended writing it off to the side so you can, I think, do the answer that question better. I don't need a 2 because those cancel. What's x cubed divided by x? That's x squared. So then put that above the x squared. And then multiply both of these terms by the x squared. And this one's kind of unique. Oh, and before we do that, remember that long division is subtraction, not addition. But this one's unique because both of these go away. So what do we do in that case? Like, you could put a 0 if you want. What would you do next? Yeah, I mean, we can bring this thing down. Bring this down. Why are we bringing both down? We have to have, on our working line, which will be here, we have to have something for both terms to work with, right? If we don't, then we're done. So 2x goes into negative 8x, negative 4 times. Again, if you're struggling with figuring that out, just set it up this way. This, we can see the x's cancel, and then negative 8 divided by 2 is negative 4. And 3 times negative 4 is negative 12. And we end up with 0. It did say, I don't know if you ever did see it, but it said to write it as a product of 2 factors. What would that look like in this case? If I wanted the answer. Okay. Guys, where we're headed today, we're going to start what we call multiplicity of zeros. What are the zeros of that function? So basically we were given this 2x plus 3 to check. We divided, we found out that the remainder was 0, which means that it is a 0. But what are the zeros? I see 3 myself. Can you do them in your head? Can you do at least one in your head? Okay, raise your hand if you can. Give me at least 1 0. Okay, a few of you. Let's talk about that one. Quit doing that. What is the 0 that hopefully you're looking at? It should be from this one. What's the 0 for that factor? Okay? It should be x equals negative 3 halves, right? So subtract your 3, divide by 2. So that's one of our zeros. If I asked you to go graph this, it would be at negative 3 halves. There would be a 0 there. Can you get zeros from this? Absolutely. How? Yeah, you would use just good old solving. So get your 4 on the other side and square roots. How many zeros does that give? That gives 2 more. It's plus and minus 2, right? So we have 3 zeros. Negative 3 halves, 2, and negative 2. And hopefully by now, actually you can see it right here. What kind of end behavior do we have for that function? Everybody kind of trace it in the air so I can see that you do get it. Okay. It should look like this, right? Opposite directions for our 2 end behaviors. We know that because it's an odd degree. The lead coefficient is positive, so it's this version. Okay. That said, we have 3 zeros. Sorry. I want you to think about this as kind of the conclusion to our unit. How can you take a function I give you and do all of this all the way through? I would go put these on the x-axis, x and y-axis. In this case, just the x-intercepts. So we have one at 2, negative 1.5 is negative 3/2, and then also negative 2. We know that it's got to trace through here like this, right? But go through those zeros. So it's probably looking something like this. You agree? Before we use the calculator to find those turning points, we don't have to do that as much now because we have the zeros. So we know that in order for the end behavior to look like this, it has to go up through that 0 and down through that 0, and somewhere in there it's going to turn. Okay? And how high it turns is not super important to me. In other words, it could turn way up here and come down, or it could be like I did before where it's just a little bump. You'll get the hang of that as you do more of them. So the only difference between this and where we'll be soon is the fact that you were given something to divide by. That's a pretty big deal because it allowed you to start breaking the function down. And number 2, we didn't have to deal with any specific multiple zeros. In other words, all those zeros only occurred one time. Okay? What we're going to start right now is what happens if those zeros occur more than once? What does it look like? It's called multiplicity. How'd this go before we do that? Just the division, how did that go? Okay? In terms of going from division to zeros, give me a fist of 5 on that for yourself, please. Not necessarily could you do it, but did you follow? Alright, good. Typically we think of it as more than one. So here's what we're looking at. Let me scroll down to it. This is too big. How many times a 0 shows up in your factor list determines how the graph looks as it passes through that 0. Okay? Here are our options. In general, we might have a linear pass-through. So if we had a 0 there, it might just go straight through. That's what we just saw in our warm-up problem. It also might bounce off of a 0. So we will see cases when that's the case. That's how it works. And then it also might pass through kind of like a snake or so, like an S, like where it does sort of what looks like a cubic function itself as it passes through that 0. Those are your 3 versions of 0 multiplicities. And we'll talk here in just a minute. How do we know which one of these it is? Once we know that, then we can make our graphs more accurate. Make sense? We can also take a graph and write an equation for it as well. So, a linear pass-through, meaning straight line through, a bounce off, or a curvy pass-through, we could just informally say right now. You don't have these pages on your packet, so I just want you to look up here. I didn't feel like you needed that in there. If you want them, let me know, and I will tell you, or I'll print it for you. Can you guys see this okay? Is this big enough? Okay, what is the 0 for this factor right here? The 0 is 1. Good. 0 for that factor? Negative 5. So you can see those here. We have 1 and negative 5. How many times do those zeros show up in our factored form? Just once. Okay? And what is going on with the line as it goes through that 0? Is it straight, bounce, or curvy? As it passes through the 0. It's straight, okay? If you just zoom right around that 0, it looks like a straight line. Don't worry about what's going on up here. Okay, let's see if it's true here as well. What's the 0 for this factor? 1. How about this one? And negative 2. So you see those up here, and you can see they're all straight through. They're just linear. How many times do those zeros occur? Once. Okay, so hopefully you're starting to see that if it's just shows up one time, it's just going to pass directly through there. Okay, and it makes sense thinking linear equations have a exponent of 1. Does that ring a bell? Okay, this one you notice there's a bounce off. And if you look at the factor for that 0, how many times does it occur in the list?
Twice.
2 times this time, right? It's squared, so that means it's showing up twice. If I wrote this out without the squared, it would be, and you will probably do this yourself. This is how you would write it, where you can actually see it showing up twice. Because it's there twice, this is going to come up and bounce off instead of pass through. It could bounce from the top or the bottom, just depending on which direction our graph is headed, but it's going to bounce off. Okay? So here we see 2 bounce offs, and both zeros have a multiplicity of 2. They show up twice. Seem okay? Okay. How do we find, let's review this. This is something we did before break. How do we find the degree in factored form? You guys remember how to do that? Well, we just need to look at multiplying these together. So x, that's going to be our degree. What do we do with those exponents when we multiply? In other words, let's write it down here. X to the first times x to the first times x to the first. We add them. So this is a degree of what? 3. So it's third degree. What would the degree of this be? X squared times x squared would be what? Yeah, so this is going to be a 4th degree polynomial, and let's look. Do you see how it's both ends are pointing the same direction? And that negative sign is small, but that's what's making it point down. All right, next page. Okay, bounce, linear pass through, bounce again. So let's see if we can make a connection. Notice our 0 at -1, multiplicity of 2. 0 at 2, multiplicity of 2. And then the 0 at 1/2 is just once, so it's passing straight through. What is the overall degree of this? Yeah, we have x squared, another x squared, and then just an x. So that's going to be a 5th degree. Does this match what we think of a 5th degree? With a positive lead coefficient? Yeah, right? All right, here's our first curvy kind of cubic pass through. Notice the factor there has a multiplicity of 3. And then that makes it kind of pause at that 3 before it heads on up. What if it was a 5th power? What do you think it would do? Like, what if instead this was not 3 but 5? Well, it's going to flatten out a little bit more, but it's still going to do that same pass through. Okay? Similarly, if this one was a 4th, it's not a good 4th. If that was a 4th power, the bounce off would still be on the 2. It'd still bounce. It would just be flattened out a little bit more at the 2. Okay? So you don't have to distinguish between too many things. If it's a 1, it passes through. If it's even, it bounces. And if it's odd, not 1, it's going to curve through. Why are we doing this again? Like, what is it going to help us do? Say it again. Graph more accurately. Because now not only do we know the zeros, but we know how the graph looks as it passes through them or bounces off. Any questions on multiplicity? I remember when I first heard this word, I thought, what the heck does that mean? But once you kind of get the idea of it, it makes sense. What color are in it? Blue, right?
Yeah.
Let's write a little note about that. I don't know. All right, multiplicity, how many times the factor shows up in the polynomial. Now, the only way to see multiplicity is if it's in factored form. Otherwise, you can't just look at a polynomial and know how many. You can't actually, just looking at a polynomial, you can't know the zeros and you can't know how many times they show up. So we got to get it in factored form. How do we get it in factored form? That's going to be how we conclude the units. But typically it's going to be, so we'll get to factored form by division. And solving quadratics. Usually you'll be able to factor these. Once you get it to a quadratic, you'll usually be able to use star. Occasionally you'll need to use the quadratic formula though. All right, in here we're going to write down the 3 versions of multiplicity. Isn't there a movie called Multiplicity? Old movie. Okay, I'm going to change that 1. So multiplicity of 1. The factor shows up once. What did we say it looks like as it passes through that 0? Straight line through, okay? So straight line through the 0. And let's do kind of a little sketch. Just goes straight through, keeps on going. Any questions on that? All right, let's do multiplicity, this time just even multiplicity. So 2, 4, 6. Do you want me to write factor shows up twice, or are you good with what it means? Now, can you interpret it from this one? Write it if you want to. Actually, I'll just put it on there. Factor shows up 2, 4, 6 times. Any even multiplicity bounces off. So something like that. Can we have a bounce off on an odd degree? Yes. If If you want to draw that example, sure, we can do that too. Do a better job though. Okay, like this one would have a bounce off, so that would be an even degree, and then a pass through would be just degree of 1, or not a degree of multiplicity. So we could see that making 2 plus 1, and then it's a cubic. That's what we expect, right? Cubics look like this. Well, one version or the other. Are you guys pretty solid on that? Do you feel like? You should assess yourself. If I say cubic, do you know it's this? Some version of it, right? It could be kind of bumpy, or it could just be smoother, but... Alright, last one. Odd, but greater than 1. So our factor now shows up 3, 5, 7, etc. times. You're not going to have, like ones that we get into the nitty gritty of working with, you're not going to have more than a multiplicity of 3. Usually. And certainly not like 5 or 7. I'm not going to give you something where you have like a 10th degree equation to factor. That would take like 2 hours. Or an hour. It would be too long. Alright. So it passes through with a curve at the 0. Oh, it's hard to see. Let's do a better job. Can you have an even degree with a curve like a multiplicity of 3? You can, so let's put an example. So remember, even degree, the arms, the two ends point the same direction. So maybe we come up through and then down, curve, and curve as we pass through the 0. So this would be 1, 2, 3, 4. This would be could be a 4th degree. Do you see that? 1, 2, 3, 4. So it makes sense that both arms point down. How's this feel? Seem okay? Okay. Quick summary. If it's even, multiplicity, what does it do? Bounces, right? Odd multiplicity, including 1, passes through. Alright, let's go to that packet. Once you have this written, go ahead and pull that up. You can take a look at that first problem if you're waiting on us. See what you can make of it. Alright, so notice all this stuff is here if you want to read through it. So sketching polynomials using zeros, end behavior, and multiplicity. It's not saying that, but that's going to be part of this. So, find all the x-intercepts. That's another name for zeros. The y-intercept can help. It's not a critical piece, but it can help. Okay, and then determine whether the graph crosses or touches. That's the multiplicity, if you want to write that on there. How many times does the zero occur in the factored form? Okay, and behavior at this point should be kind of routine. Oh, how about this one? We forgot to review this. I did. Do you remember how to know the maximum turning points? What was it?
I believe it was the degree minus.
Perfect. Degree minus 1. So a fourth degree has a max of 3 turning points, right? That's just to help you graph it. All right, so let's go. The rest of that is basically the graph part. Well, this is, what degree is this? Second degree. We called it a quadratic in the last unit. So before we do anything, how many turning points can it have? 1. Okay. End behavior. Is it pointing same direction or different? Different, pointing up or down? Wait, you said different. It should be the same. Same. Is it pointing up or down? Up. Okay. So we're expecting something like this, right? But how do we get it onto the grid? Like, how do we situate it just right? Well, let's factor this. Can you factor this in your head? If not, do the star. But it should be plus x plus 5, x plus 5. Okay? If we solve for the zeros, what are our zeros? So this is factors. Factored form. Zeros, what are our zeros? It's just negative 5. What's the multiplicity of that 0? Like if I wrote this, couldn't I write it as x plus 5 squared? Because there's 2 of them. So the multiplicity is 2. So is this going to bounce or pass through? Bounce. Okay. Alright, so we go put our 0 on negative 5. And we bounce this off. I'm not going to be super specific about your graphing pattern, meaning how it looks up here. I wouldn't do the extreme case and make it super skinny, because you know it doesn't look like that. Also, I wouldn't make it the super wide case, because you know it doesn't look like that. But in terms of this paper, I'm looking for, do you know the zeros, do you know the multiplicity, and how it affects the graph? So we're good. Okay? Any questions on that one? Okay, let's go to the next one. So we want to write it in factored form. And I'm going to give you a second to do that. Maybe do your work here or so. So take a minute, and that's fine. So, like I said, we want to look for a GCF, which in this case is x squared. That x squared is a 0. Do you see it? If you don't see it as x squared being a 0, write it as x minus 0 squared, and then it looks like it looks like what you're used to maybe. Okay? But x squared, that's one of our zeros. So now we need to factor this guy to what? Well, do your star, you'll get x minus 5 and x plus 4. I'm going to scoot this one over a little bit. Good? How many of you did the star? Okay, good. Awesome. So our factored form, I'm just going to draw an arrow. That's our factored form. Again, you don't need the x minus 0. It's okay to just write it as x squared. Okay, what are our zeros?
Negative 4, 5 is 0.
X equals 0, x equals 5, x equals negative 4. Okay, multiplicity. This time we have 3 zeros, so we need to write the multiplicity of each one. Let me change the color of that. What's the multiplicity of x equals 0? 2. Do you see how it shows up with the squared? So it's 2. How about the other 2? Just 1 each, right? They only show up once. So what will the graph do at x equals 0? It will bounce. And then how about at x equals 5 and x equals negative 4? It'll just, yeah, straight through. Straight. Okay. How about, it doesn't have, I'm not using A, B, or C for this, so what about end behavior for this? I wrote it in the last example as expect, but in terms of end behavior, what are we looking at for this? Yep, so it's positive even, so it should be something like this, right? It's going to point up. So let's go put that in here. Let's graph our zeros first. Okay, here's some advice. Your graphs will look better if you draw the end behavior above your zeros. In other words, we have not seen any of these, don't draw this, that look like this, right? Like, that are way out here, weird looking. You agree? So we know that the end behavior will be up here and up here, pretty close to right above these last zeros, especially the linear pass-through ones. Make sense? Okay, so we know it has to pass through negative 4. So where is this line headed? Straight down, right? Okay. We know it has to bounce at 0. Which side is it going to bounce off of, top or bottom? It's going to have to bounce off the bottom. So bounce and then come back down. And then we know it has to pass through on the 0 at 5. So something like that. Good? Things we don't know about it. This could come way down and bounce like that, right? Or it could just barely do it at all like that. We don't know that for sure. So that's not going to be part of what we need to worry about. We just want to get the basic shape. We'll get better at that as we do more. We'll know if it's farther down or higher up. Okay, how's that feel? Circle number 3, please. And 4, I'm going to have to teach you a different factoring style. You could do 5, though. So number 3, 5. And I want you to try number 6. So 3, 5, and 6. This one is set up to be an upload, so you'll be able to upload that for